Figure 17, it gives us two triangles. These triangles, we have a corner 50, 60, 50, 60. Top has to be 70. Everything's in proportion. It tells us they're similar. It says, hey, find x. Well, I can see the x is going to correspond to the 12. So I have x corresponds to the 12. Now I need two other measurements that correspond, one from this guy. The only measurement I have is the altitude, but I do have the altitude there. The altitudes will be of that same scale. I mean, if you multiplied everybody the sides by 2, the altitude will get multiplied by 2. Everything's going to grow at the same rate. Okay, everything stays in proportion. Altitudes, all of them will stay in the same. So we have x corresponds to 12, as 6 will correspond to the 8, and that'll help us find our missing value x, what this length is of this triangle. So we could simplify 6/8 to 3/4, but we'll just go ahead and go 8x equals 6 times 12, 72. And I know 8 times 9 is 72. Divide both sides by 8, you get x is 9. So that missing measurement must be 9 for figure 17. Figure 18. This time they actually want us to find the altitude. Again, it tells us the two triangles are similar. So x corresponds to the altitude over here of 6. Now, I have to set up, who am I going to use? 8, 12, 15. Well, if I look at my small guy over here, this guy only has the 5. So I have to figure out who's corresponding to him. Now, I got to pay attention. 50, 60, 70, 50, 60, 70. So yes, it is set up perfectly that this 8 and 5 are in correspondence. So we did x is to the 6 as the 8 is to the 5, as the 8 is to the 5. Now I can cross multiply or apply the means extremes or butterfly method. 5x equals 8 times 6. 8 times 6 is 48. We divide by 5. 5 goes into 48 9 times, because 9 times 5 is 45 with 3 left over. Add a 5, which is 9.6 for our altitude here on figure 18.